part 2, we're going to talk about some new formulas. Now, if you remember, the Pythagorean theorem only works on right triangles. And if you remember SOHCAHTOA, we will review it later, only works on right triangles. But there are a lot of triangles in the world that are not right triangles. And so this law of sines works for all triangles. So it's pretty handy. And what it says is really, if you know an angle and its side, and you know any other angle and its side, as long as you know 3 or 4 pieces of information, you can set up a proportion, cross-multiply, and solve. So the way this works is we're always looking for an angle and its side opposite. Now, important note, there's naming conventions with triangles. Capital letters on the vertices all the way around, corresponding lower case, capital J, its side opposite, lowercase j. Capital K in this vertice, lowercase k directly opposite. And that's so that when we go to name these, we are always talking about the exact same sides and angles and their relationships. So in trig, if it says solve, it wants 3 answers. Whatever you don't know, you need to find. You need to find all the rest of the information. So easiest thing with K is that 3 angles always add up to 180 in a triangle. And so I know that angle K is going to be equal to 180 minus 70 minus 38. That's one of the easiest things to look for. And so that means that angle K is 72 degrees. So then I go back and see about finding these sides. Obviously, Pythagorean theorem doesn't work because this isn't a right triangle. So what I can do is I know H and its side opposite. And so the first thing I can set up is, I could do this. I could say the sine of 38 over its side 6 is equal to the sine of 70 over its side. So now I have a cross multiply problem. And so I have 6 sine 70 is equal to j sine 38. And remember, the sine of 70 and the sine of 38 are numbers. So now I want to get j by itself. So I divide both sides by the sine of 38. And I go to my calculator because those are going to cancel. And when I go to my calculator, I want to be really careful how I enter this stuff in, and you may want to do it in pieces. So I'm going to say 70 sine times 6 equals divided by 38 sine equals. And so j is 9.16. And that's how long that side is. Then I basically start all over, and I need to find little k. So I'm going to start with what was given here. Always use the given if you can. The sine of 38 over 6 would be equal to the sine of 72 over the side I don't know. And again, we're going to cross multiply. And so we'll have k sine 38 equal to 6 sine 72. Notice I always put that constant out in front of the trig ratio, and that's so that there's never any confusion what the size of the angle is. It's not a 72 times 6 angle, an order of operations problem. So divide by the sine of 38. That cancels. And so I'm going to go to my calculator, and k is, clear, 72 sine times equals divided by 38 sine equals, and it is 9.27. Oops. Random line shows up there. K is 9.27. Get that line out of there. Okay, so that is how you would solve that triangle. So I've got one answer, two answers, three answers. Okay, so now we're going to, I'm going to erase this work, and we are going to work on finding S and T. So the second example is actually only asking us for two angles. It's not asking for the third side. So in this scenario, we are going to figure out where we have to start. Sometimes you can start anywhere, but in this case, we only have one choice. This is our given. We know this side, it matches with this angle. We don't know enough about t because we don't know anything over here to find t to start with. So the first thing we're going to find is s. And so we are going to say the sine of 53 over 5 will be equal to the sine of s over its side, 5.26. Now this is one where we're going to have to use that inverse feature at the beginning. So we're going to solve for a decimal, and then we're going to undo it to find the angle. So we're going to cross multiply. We're going to say 5 sine of s is equal to 5.26 sine of 53. Divide by 5, because the sine of s is our variable. And so then we're going to go to our calculator, and we are going to say 53 sine times 5.26 equals divided by 5. A decimal less than 1 is what I expect, and so I like to write things down. And so at this point, I write that the sine of s is equal to 0.84. But I don't want to enter that in my calculator. I'm actually going to leave this big decimal, and I just put that down for checking. And then I'm going to say inverse sine inverse. It's a 57.2 degree angle. So S is 57.2 degrees. Now that makes finding T very easy, because angle T is equal to 180 minus 53 minus 57.2. And when I go to my calculator and do that, I find that angle T is 69.8 degrees. And so there are my two answers for using the law of sines. Tune into part 3 for the law of cosines.